Every year, humanity generates more than 2 billion tons of waste. For most of us, taking out the trash is a mindless habit. Once the bag hits the curb, we assume its story is over. But inside that bag sits a densely packed bundle of unrefined commodities waiting to be mined. The local garbage truck rolling down your street acts as the initial transport vehicle in a massive global logistics network. Extracting pure value from all this chaotic debris forms the foundation of a hidden, multi-billion-dollar industry. The moment your waste leaves your home, it enters a carefully organized system, arriving first at a vast transfer station. Here, thousands of tons of chaotic debris are dumped onto the floor to begin processing. The primary engineering challenge here is separation. Facilities have to take this contaminated mix of household waste and divide it back into distinct, pure material streams. The process begins with mechanical triage. Massive conveyor belts and gravity sorters sift out the large, obvious items. Next, artificial intelligence takes over. High-speed optical scanners watch the remaining debris slide by, instantly identifying specific recyclable materials based on their shape and composition. Once the AI targets an item, robotic sorting arms execute the physical extraction. They rapidly dart across the belt, plucking out valuable plastics and aluminum. Modern recycling facilities operate as reverse manufacturing plants. Their single purpose is turning finished consumer goods back into raw industrial ingredients. Once those materials are sorted and baled, they move to global cargo ports. Bales of sorted plastic bottles, compacted aluminum cans, and steel are now global tradable assets. What your garbage is actually worth fluctuates daily, driven entirely by international manufacturing demand and shifting commodity prices. This chart maps the value of raw recyclables against processing costs. When demand pushes prices above this break-even line, processing is profitable. Below it, it's unviable. When profitable, an aluminum can is melted, reformed, and restocked in mere weeks. The entire recycling industry operates as the global commodities market functioning in reverse. Materials that cannot be profitably recycled are routed to a different destination, the vast engineered landscapes of modern landfills. This modern landfill cross-section shows engineered bottom liners, drainage systems, and compacted waste cells that contain toxic runoff. Inside, decomposing organic waste produces methane gas, which rises into dedicated extraction pipes and feeds into surface-level generators, converting gas directly into electricity. This secondary revenue stream means a landfill operates as a long-term, energy-yielding corporate asset. The ultimate goal of all this global infrastructure points toward a single concept: the circular economy. The traditional linear model, take, make, and dispose, fades out here to reveal a circular economy. Inside this infinite closed-loop cycle, products are designed to be repaired, reused, and recycled, keeping materials in play indefinitely. Achieving this globally requires immense infrastructural upgrades from corporations and a complete shift in consumer habits. In a fully circular system, garbage is revealed to be a temporary classification for materials we haven't figured out how to use yet. Every time you throw something away, you are feeding a massive industrial machine, where one person's trash becomes an international treasure.